Okay, so this question came in 2023, final exam for 1010, and this question had 10 marks. So the question is, a vector A has a magnitude of 30 meters at an angle of 200 degrees with respect to the positive x-axis. If we add a vector B, it is found that the resultant is along the positive x-axis and has the magnitude of 30 meters. The question now is, what is the magnitude of vector B and its direction? Okay, so if I may ask you guys, for us to find the magnitude and the direction of a vector, according to your experience so far, what are we supposed to do? Anyone who can help us? Okay, so now if you have been given any vector, the only principle which you have to follow there, guys, is to resolve each vector into x and y component. When you resolve a vector into x and y component, then solve the remaining part. Okay, so like in this case, we have been told that we have got vector A and B. Then we have got also the resultant. So we are saying that if we add vector A and B, it was found that the resultant is along the positive x-axis and it has got the magnitude of 10 meters. So we need to come up with a free body diagram. So in this case, our free body diagram, I'm going to use an xy plane. So if this is my xy plane, we have been told that we have got vector A, which has got the magnitude of 30 meters at an angle of 200 degrees with respect to positive x-axis. When we are dealing with vectors, we are measuring the angles from positive x-axis. One thing you have to remember, guys, is that whenever we're talking about positive x-axis, this is positive x-axis, this is negative x-axis. So the vector is starting from this line going anti-clockwise, not clockwise. So that's how we measure the angle. So in this case, we have been told that the angle is 200 degrees. Now, where can we find 200 degrees? Is it in the first quadrant, second quadrant, or in the fourth quadrant? Okay, so 200 degrees we can find it in the what? The third quadrant. Then I'm going to put this vector here to say that is vector A. I'll put it there. Vector A is 30 meters. The angle is from this line here, guys, all the way until it touches the vector. That is our 200 degrees. Now, vector B, we don't know where it is, but we've been told that when we add this vector B to vector A, it was found that the resultant has got the magnitude of 10 and it is moving toward the positive x-axis. And we already know that toward positive x-axis, the angle is 0. Meaning that in this line, that's where my resultant is, which is 10 meters. After doing this, resolve each vector into x and y component. We are trying to see on how we can get all the marks. Okay? So what I'm going to do now is, we are saying that if we add vector A and B, the resultant is going to be 10. So let's resolve each vector into x and y component. I'll start with A. To resolve any vector into x component, we use cos theta. So I'm going to say A x, my A vector is 30, cos the angle, in this case the angle which we're going to use is the angle coming from the x-axis all the way until it touches the vector. So I'll say cos 200 degrees. So what is my AX? I'll get my calculator. I'll say 30 cos 200. Okay, so I'm getting negative 28.19, negative 28.19 meters. Since I don't have enough space here, allow me to put this ax here, negative 28.19. That is my x component of vector A. For the same vector, we need to find the y component. I'll go ahead and say the y component is supposed to be A, that vector sine the angle. So AY will be the vector we're talking about is 30, sine the angle we're talking about is 200. So AY will be, we'll say 30 sine 200. I'm getting negative what? Negative 10.26 meters. So I'll just put it here. I'll get this and put it down here, so that I also resolve for B. I don't know B, so what I'm going to do is, meaning my BX, in this case, the BX I don't know it. Okay, my BX in this case I don't know. Also my BY I don't know. Okay, what of the resultant? We know the resultant, guys. So what we can do, we can now resolve the vector which is the resultant vector into x and y component. Is that okay? Anyone who is lost so far? Any question? Anyone who is lost before we continue? Yes, please ask.
Sir, can you repeat? I don't know what you did to find the x component.
The x component
Components
for A, both y and x.
for A. Yes.
Okay, so we are trying to, when you are finding the component, what you do is, for x, you get that angle, you get that vector cos phi, the angle. So in this case, the vector for A is 30 and the angle is 200. So you just plug in the values. That will be now the x component. Is that okay?
Yes, thank you.
Then for y, what you do for y is, you get this ay, you say vector A sine the angle. So A you have already, you also have the theta. You plug in the values, that is our ay here. We are cool there. We can continue. Now,
Yes, we can.
let's find our vector, the resultant now. So the resultant, guys, is r. So this r is going to be, the rx will be the vector r cos the theta, meaning that my rx will be, my r itself, the vector is 10, cos, what is the angle? As long as you have been told that the vector is moving toward positive x-axis or toward the east, the angle is always 0 degrees. If you have been told that the vector is going toward south, the angle is 270. If a vector is going toward the west or negative x-axis, the angle is 180. If a vector is going toward north or positive y-axis, the angle is 90 degrees. Those four, they are very, very important. You need to know them. So say them again, sir. Say them again. Okay. So if you have been given a question and then they are telling you to say if a vector is going toward east, let me just do this. Let me just show you a very simple compass here. So let's assume that this is our compass here. So this is north At the same time, this is positive what? Y. This is positive x, at the same time it is east. This is south, at the same time is negative y axis. This is west, at the same time is negative x axis. Sometimes they can use negative x axis, or it's the same as when they say negative x axis, it's the same as we're talking about the vector is going toward west. So this line here, since we are measuring the angles from this line all the way until it touches the vector, meaning that if a vector is going toward west or toward negative x-axis, the angle is 180 degrees. If a vector is moving or is going toward west or toward negative x-axis, the angle is 180. We're cool there, right? Now, if a vector is moving toward east or toward positive x-axis, get me right there. If a vector is moving toward east or toward positive x-axis, the angle is 0. Like in this case, we have been told that the resultant, it is found that the resultant is along positive x-axis. Definitely what should come in our mind is that the angle is 0 degrees. If a vector is moving toward north or toward positive y axis, the angle is 90 degrees. So here 180, here 0 degrees, so here is 270 degrees. As simple as that. Is that okay? We can. Is that cool, guys?
Is there a situation where
Is there a situation? Is there a situation where what, sir? What are you saying? What's your question, sir?
Yeah, I said, is there a situation where they can tell you northeast
Yes,
or
okay, I'm going. Yes,
they don't give you the direction?
I'm going to teach you
That's
that
why
one.
they don't give you the
I'm going to teach you that one. Yes, yes. But for now, let's first focus on this one. I'm going to teach you that one. So now, in this case, we are trying to find. So this is another principle. In this case, I'm going to explain everything which you need to know under vectors. So my Rx in this case is going to be, what is 10 cos 0? 10 cos 0 is 10. Meaning that my Rx is just 10 meters. Then now let's find the y component. So the y component, guys, is going to be Ry will be equal to R sine theta. So R is 10 sine 0. What is 10 sine 0? 10 sine 0, it should be 0. So Ry is 0. Now, when you find there is the x and y component, the next thing what you have to do is add the x component alone and the y component alone and see what is missing. Then that's what you're going to find, definitely. So we are saying that if we add a and b, we'll get the resultant. Meaning that if I add ax plus bx, I should get rx. Not so. If I add the x alone, I should get the rx, because this is my resultant. If I add a and b, I need to get the resultant. But in this case, we are dealing with x. So I'll say ax plus bx is equal to rx. We have ax, which is negative 28.19. But I don't know bx. And our goal is to find the magnitude of b. We have rx, which is 10. Our goal is to find bx. Shift this to the other side. You remain with bx to be equal to 10 plus 28.19. What is our bx? Our bx is going to be 10 plus 28.19. So I'm getting a 38.19 meters. That is the x component of my vector b, this one. Let me even put it here. Let me even put it there. The next thing, I have now to go to y. I'll also say, I'll use the same principle. I'll say ay plus by is equal to ry, because we're dealing with r, we are dealing with y. So what is ay? Ay is 0. By we don't know. It's the one we're trying to find. Ry, ooh, ay is not 0, but ry is the one which is 0. Ay is negative 10.26 plus by we don't know, then ry is 0. Guys, shift this to the right hand side. So it's going to be by is equal to 10.26 meters. This is my y component of vector b. But the question is, find the magnitude and the direction for vector b. When you have the x component and the y component of your vector, what you have to do is just get that b, put an arrow on top. This arrow which I'm indicating on top there, it symbolizes, is a vector. It has got a magnitude and direction. If you just say b, this is a scalar. So a vector can be represented by an arrow on top or a modulus. Don't report a vector to be just b. You are talking about a scalar quantity. Okay? Sometimes the people who are going to be marking your papers, they might mark, yes, but some they might mark you wrong, because they will tell you to say this is a scalar quantity. It's not a vector. A vector, you have to put an arrow on top, or it has to be in the modulus. Is that okay, guys? So if you have the x and y component, the next thing what you are going to do is you are going to put in the square root. Then you get the x component, you square it, plus the y component, you square it. As simple as that. Let's plug in the values. Our x component of b is 38.19. I square it, plus that one is 10.26 squared. Let's see. 38.19 squared plus 10.26 squared. I get the square root of this. I'm getting 39.54. Can you confirm with me there? I'm getting 39.4 meters. Confirm. Those having calculators. Yes, please.
39.5.
39.5, right?
Yes.
Okay, okay. So now, another part. Now, this part which we have done here, we also want to find the direction. You know, a vector, guys, whenever we are mentioning about a vector can't stand alone without the direction. Yes, please. Yes, you can ask. You can ask if I've got a question. Okay. If not, then let's continue. Now, you need to be very much careful when you are finding the direction. This is where we lost a lot of people last year. So I don't want you to get lost here. 39.54 Are you guys able to see my screen?
I'm not able to see.
Okay, you're not able to see it. What of now? You can see it? You can see now?
Yes, 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 yes.
Okay, okay. So I believe you are there when the time I was finding 39.54, right? Okay. So now you can just mute the mic. You can just mute your mic. When you are finding the direction, I want you to get me right there. The direction you need to understand, guys. Simple principle. Very simple and straightforward. Let me just get rid of this. How do we find the direction of a vector? I'm going to teach you on how to find the direction of a vector. Based on the information I'm going to give you right now, you are going to tell me before we even find the answer, you should be able to know whether the angle is going to be in the first quadrant, second, third, or fourth quadrant. There we go. So if this is my xy plane, I know that this is my first quadrant, this is my second quadrant, this is my third quadrant, this is my fourth quadrant. Guys, you know that this is positive x-axis, positive y-axis, negative x, negative y. Now, you are trying to find the margin, you are trying to find the direction of a certain vector. Let's now say, let's assume that you discover to say your x component of that vector you are finding is positive and the y component is also positive. Get me right there. You resolve the vector, you have come up with a conclusion that okay, this is my x component of the vector and this is my y component of the vector. If they are both positive, if x is positive, y is positive, definitely the angle is going to fall in the first quadrant. Before you even solve, you will be able to know that the angle has to be in this quadrant, because in the first quadrant, that's where I can clearly see that x is positive and y is also positive there. Now, if you discover to say the angle falls in the first quadrant, we know that when finding the direction, we always use this formula. We say theta is equal to tan inverse the y component divided by the x component. When you find the answer using this formula, the theta you are going to find here, that is the answer. That theta is going to be our answer. Direct. The theta I'm going to find, because it falls in the first quadrant, that is going to be my answer. Then I'm done with that question. Now, if I discover to say the x component is still positive, okay, let me change. The x component is negative and the y component is positive. Definitely I need to think of the second quadrant, because in the second quadrant, this is positive, and this is negative. Definitely the answer has to be in the second quadrant. So the answer has to be in the second quadrant. Now, in the second quadrant, I've given you to say x is negative, but when you're plugging in the values here, ignore the negative. Don't consider that negative. Just ignore it. No one is going to penalize you guys. Ignore it. Plug in positive only in this formula. When you put positive values there, the answer you're going to find, if you discover that the angle has to be in the second quadrant, the answer you are going to find here, you say 180 minus the theta you are going to find here, because it falls in the second quadrant. Get me right there. Before we go to the third and fourth, if you have got a question, ask. We're okay? We are good to go?
Can you please repeat yourself on that?
Which one? The first quadrant or second one?
Quadrant, second quadrant.
Okay. So I'm saying that if you find that the vector, the x component of that vector, if you find that the x component of that vector is negative and the y component is positive, so I can clearly see that in the second quadrant, this line here, guys, this line is for positive y, and I can see that I have got positive y here. This line here is for negative x, and I have got negative x there, meaning that the angle is in the second quadrant. So in the second quadrant, when you find that the angle is in the second quadrant, using this formula, when you plug in the values, remember that x is going to be negative, but just ignore the negative, plug in positive values only. When you find the theta, which you are going to find here, you are supposed to say 180 minus theta, meaning that is the direction you are looking for. If I made myself clear?
Yes, thank you. I've understood.
Sure. So if now you resolve your vector, you find that the x is negative, the y is also negative. Based on this information, based on the first part and the second part, where do we expect our angle to be in this case? Anyone to volunteers? Yes. Yes. Yes, it's going to be in the third quadrant, because in the third quadrant, that's where we can see that this line here is for negative y and this line is for negative x. So definitely it has to be in the third quadrant. Now, in the third quadrant, don't make mistake, guys. Don't make mistake to say 270 minus the theta. No. Under vectors, that doesn't exist. That is now meaning we're talking about math now. Under vectors in physics, we don't subtract from 270. No. So you say 180 plus the theta you are going to find when you plug in the values using this formula. 180 plus the theta if the angle falls in the third quadrant. Get me right there. Don't say 270 minus theta. That is wrong. Is that okay? Can you do the last one, the fourth quadrant? So if x is positive, y is negative, definitely it has to be in the fourth quadrant. What do we do if the vector falls in the fourth quadrant? This is where now, when you plug in the values, remember you only put positive values in this formula. This formula. Tan inverse y divided by x. Just plug in positive, ignore the negative, then follow this principle. So now, if it falls in the fourth quadrant, you say 360 minus the theta you are going to find here. That is the direction you are looking for. Guys, under direction, any question, I believe you can solve. This is the only trick part when it comes for when it comes for direction under vectors. You need to know before you even solve. Now I can ask you the question. Here we are trying to find the direction. I'll get rid of this everything here. We are trying to find the direction of vector b. Now vector b has got the x component of 38.9.19 and the by of 10.26 meters. Who can tell me before we even solve, where do we expect this angle to be? Is it in the first quadrant, second quadrant, third quadrant, or fourth quadrant? Let's see. Where do we expect it to be?